this video we'll talk about skewness. Now, it is also a very important topic and one of the fundamental concept in statistics. And there are three kind of questions related to this skewness are asked. And what kind of questions are asked can be asked related to this topic? There are three questions. Number one, what is skewness? Right. Number two, why it is important, and number three, give some examples, classical examples where it can be used. Now, this video will be in two parts, right? So now the question is, what is skewness in the data? Now the skewness basically describes, or if I can say, it basically quantify or measure the if the probability distributions deviate from the normal distributions, or I can say how much probability distributions deviate from the normal distribution, right? This is the normal distribution, right? If we talk about the skewness of this data, this normal distribution, it is almost near to zero, not exact zero, but almost near to zero. If we talk about this distribution, the skewness of this distribution is zero almost. And if we talk about this one, there is a high skewness in this result because it is deviated from the normal distribution. And if we talk about this one, it has also high skewness. Now basically there are two kinds of skewness in statistics. The one is right skew and the second one is left skew. And what is right skew, what is left skew? The right skew is, you can see here, the right skew, you can see the distribution tail is to the right side. The distribution's tail is to the right side, and the hump, you can see here, the hump represent the lot of data set. In the right skew, the hump will be representing the high lot of data set at the lowest values, lowest points. You can see the values of this right skew is 10, 20, 30, 40, 50, 60. Remember this thing, in a right skew, the hump you will get always at the lowest points, lowest values. Here you can see the 20, 30 is a comes in a lowest value compared to this. This is the greater one, but hey, these are two are low values. So in the right skew, there will be a lot of data set at the lowest value. Here you can see the between the 20 to 30 there is a lot of data set here, and a lot of the reason why there is a hump. In the normal distributions, the many data set you can expect at the zero, at the F center, right? And if we talk about the left skew, in the left skew you can see the distribution tails is to the left side. Reason why it is known as the left skew, and you can see in the left skew the hump is at the highest value. It will always be like that. In the left skew, there will be a lot of data set at the highest point, highest value. You can see the 10, 20, 30, 40, but there are a lot of data set at the between 40 to 50. So that is what the left skew and the right skew are. Now apart from this, there one more concept. In the normal distribution, the relationship of a mean, median and mode are almost similar. You can see almost at the one point. In the right skew, the mean is greater than median and median is greater than mode. Now question is, why is mean is greater than median and mode? If you remember, the average value is always affected or influenced by the extreme value. Here you can see the extreme value here, right? Obviously the mean will be always be influenced or affected by the largest value. So reason why, if you calculate the mean, it will be always be greater because there is a large value. Similar to here the tail is toward this smaller value, and when we calculate the mean, it will always be less. And reason why the mean is all less than median, and median is, you can see the mode is greater than median is greater than mean in the left skew. It is the relationship in left skew data set where the mode is greater than median is greater than mean. In the right skew, the mean is greater than median and median greater than mode. We can also represent this right skew and the left skew in the box plot. Now in the if the data is normally distributed, right, the skew the box plot will be showing the 25% data set here, the whisker 25% data set here, 25% data set here, and 25%. These are normally distributed. The reason why you can see the data is equally distributed. But if you talk about the right skew, in the right skew you can see to the left side at the lowest values there are a lot of data compressed here. There are a lot of data set. That is how the right skew data set, right skew is represented in the box plot, where the green region showing there is a lot of data set there. You can see there at the lowest value at the 2030 the data set is high, similar to here. If we talk about here, it is equally distributed. In the left skew there are a lot of data set at the highest point, at the largest point. Similar, we can see the green region showing there are a lot of data set compressed here at the largest point, right? So that is how we can show the box plot of the right skew and the left skew. Now the question is, what are the classical examples? What are the classical examples where it can be used, right? So let's take the example. In Pakistan, there are 64% populations is below the 30 age. 30 age means 64% of populations are below 30 years. So how we will represent this? If you can see here, there are 10, 20, 30, 40, 50, 60. Means it is telling us there are 64% data set below the 30 age. Obviously the lot of data set will be lie between here. You can see here there are a lot of data set, so it will be look like this, which is the right skew, because there are many data present in the lowest point. Obviously the age below the 30 representing here, right? If we talk about another example of the right skew, right, in the right skew, if we talk about, there are new kind of disease, there are spread in the city, and mostly below the 30 ages are affected of this disease, which is a skin disease, let's suppose, right? Now this is the representation of a patients whose age are 10, 20, 30, 40, 50 and 60. So from here you can conclude, to get a conclusion, the skin disease is affecting more those whose age is between 20 to 30, right, as compared to the adults or more than 30. though these patients are not affected more compared to those patients whose age are 20, 30. So these are kind of example we can give, right? If we talk about another example of a right skew, right? Let's suppose we also this distribution also represent the wealth distribution. Wealth distribution means, right, here in this tail, now those person are richest person, like Bill Gates and Elon Musk. These people lie here. But no, lots of population, lots of population lie at that point. Those who does not have so many, properties or wealth like that, as compared to the richest one. So we will lie here, because mostly person are not as much richer as compared to Elon Musk and Bill Gates. They are very very rich people. If you talk about the left skew scheme example I can give here. Let's suppose we want to see which group age are earning, you know more than 50K in a salary. Which age group is earning more than 50K, right? If you see here, if you say here, now here this left skew is showing the age group between 4 to 50. Age group between 4 to 50 are earning more 50K, right? So that is kind of example. Another example I can give here. Let's suppose if we talk about the heart patients, right? Heart patients. Now we want to see which age group are affected by heart disease. So if the data is present in here, we can make a conclusion here, right? Those patients whose age are between 40 to 50 are more affected. Because there are a lot of data set here. Those who are between 40 to 50. So from here we can make a conclusion like that we should give preference to those patients who are aged between 40 to 50, right? This kind of examples I can give. Another example of the right skew I can give here. For example, if we talk about the food panda and the food panda delivery boy, right? I have a data set of a food panda delivery boy, and this data set representing the age of those delivery boys, right? Now we can see here, now age group between 20 to 30, there are a lot of data set here. Means in food panda, the delivery boys have age between 20 to 30, and from here we can make a conclusion. Those who are working as a delivery boy in a food panda have age between 20 to 30. So we can make more conclusion from here compared to the other, right? So that is how we can use the skewness distributions. So that's all about this video.